Okay, today's lesson is section 5.3. We are solving quadratic equations by finding square roots. Solving quadratics by finding square roots. Okay, now this isn't going to work on all of your quadratics, okay, but it'll work on some, and when it does work, it's actually going to be the easiest way to solve for them. Okay. First thing we got to remember is what a square root is. Okay, remember a square root looks like that. This is called a radical. Right? And any square root we want to have is some number times itself. For example, the square root of 4 is equal to 2 times 2. Okay? Or 4 is equal to 2 times 2, so the square root of 4 is just 2. Okay? Now, that's not necessarily important. I'm going to figure you guys probably remember that. Okay? What I need to make sure you guys know is this, that the square root of AB is equal to the square root of A times the square root of B. And that might be a new idea for you guys. If you were in my geometry class last year, I know we talked about it at least. I'm going to assume that you probably talked about it at Mr. Sweetzer's as well. Okay. We also need to know that the square root of A divided by B is equal to the square root of A divided by the square root of B. Okay, so those are the two main ideas that we are going to have to work with to simplify our radicals. Okay? The solving with radicals is the easy part. Simplifying is the more difficult part. Now, let's do a couple examples of these ideas. First one, I have the square root of 24. Now, it might not look like either of these specifically, all right, but we need to break this down. Okay? I know that there's two numbers being multiplied here, right? And the way I've always showed my classes how to break it down, and I think is the easiest way, is break it down like a factor tree. Okay? What multiplies to 24? Well, the most common thing is 6 and 4. Okay? There's also 8 and 3. Either of them will work. Okay? I'm going to use 6 and 4. Now, my square root does not go away, so I still have the square root of 6 times the square root of 4. Okay? Notice I took out a perfect square. When I divide this down, I always want to divide into a perfect square. Keep in mind, and maybe write this at the top of your page, your perfect squares. Okay? Your most common one is 4, then 9, 16, 25, 36, 49, 8, etc. Okay? Now, I always want to take one of these out. So notice, I took out a square root of 4 because it's a perfect square. The reason I want to do this is because now the square root of 4 is just 2. Right? Now I need to ask myself, can I take a perfect square out of 6? Can I take a 4, a 9, 16, 25, 36, 49 out of 6? Well, I can't, so this is not going to change. Okay, so now I have the square root of 6 times 2. This is all the farther I can go, but I have to do some rearranging. You always put your radical last. So I should have 2 square roots of 6. Alright, the next problem they just give us in a little bit different form. They give us the square root of 6 times the square root of 15. Alright, and they want us to simplify this. Okay, they want us to simplify the expression. So our first step, we need to get this stuff combined Because I know if I'm multiplying two radicals that I can write it under one radical. Okay, so let's multiply 6 times 15, which is the square root of 90. Don't forget your radical. You have to have that there or it's not going to be correct. Alright, now I need to look here. Now I have to reduce my radical. So I want to come up here, look at my perfect squares. Can I take one of these out of 90? Most common one, and hopefully you found that 9 goes into 90. So I break this down. I have the square root of 9 times the square root of 10. Notice, 9 times 10 is 90. Right? Well, can I break the square root of 9 down? What is the square root of 9? And this should be 2. Excuse me, not 2. 3. The square root of 9 is 3. Now, I also have the square root of 10 over here. Question is, can I take a perfect square out of 10? Can I take out a 4? No. Can I take out a 9? No. Obviously, I can't take any of these out because they're bigger than 10. So I'm going to leave it as the square root of 10. So my final answer is 3 square roots of 10. Remember, if you need to watch me go through that process again, go ahead and rewind. All right, you're watching independently, so take as much time as you need. Rewind, watch it again. Okay. Let's take a look at dividing. I have the square root of 7 over 16. Okay, the square root of 7 over 16. Now, with this, keep in mind again, these rules that we talked about earlier. Okay, if I'm dividing inside a radical, I break the radical up and write it on top, and I write it on the bottom. I write it on top and on the bottom. So I come down here, instead of the square root of 7 over 16, I have the square root of 7 over the square root of 16. What is the square root of 7? Is there anything I can take out? Any perfect squares that I can take out of 7? 4 doesn't come out of 7, and 9 is bigger than 7, so we're done already. Okay, there's nothing that can come out. So I still have the square root of 7 on top. It's okay to have a radical in your final answer. That's alright. Okay, what is the square root of 16? Okay, that's nice and easy. They gave us a perfect square here. So the square root of 16 is 4. And that's all the further we can go because we cannot simplify this. And there's nothing out in front that I can simplify with a 4. So we are done. And if you're lucky, they'll give you nice easy ones like that every time. But I'm not thinking that's probably going to happen. Next one. I have the square root of 7 over 2. And this is where it gets a little bit more challenging. Now, here, okay, first break it up, square root of 7 over square root of 2. Right? Our problem is that neither of these will break down. Right? They are both non-perfect squares, and there are no perfect squares, these, that go into either of them. Okay, so we're kind of stuck here. A lot of you would consider this your final answer. The problem is that we cannot have a radical, remember a radical is the square root sign, we cannot have a radical in the denominator. Numerator, denominator, okay, keep that in mind. We can't have a radical down here. And we have to get rid of it. So we are going to do what we call rationalizing the denominator. Or in parentheses, getting square root out of the denominator. Okay, that's called rationalizing the denominators. Get the square root out of the denominator. I know you guys can't do that, but find something on your page to rewrite this. And to do this, I have to multiply by this exact radical down here. And so I want to multiply by the square root of 2 over the square root of 2. Now the reason I did it on top and on bottom, because remember, if we look just at this, the square root of 2 over the square root of 2, that's 1. Anything over itself is just 1. Alright, so I'm not actually changing this problem, I'm just writing it in a different way by multiplying by 1. Okay. Well, what is 7 times the square root of 2? Okay, coming back up here to our rules, we should know that two radicals times each other can go under one radical. Okay? So 7 times the square root of 2 is the square root of 14, and 2 times the square root of 2 times the square root of 2 is the square root of 4. Okay? Well, that didn't really get us anywhere because we still have a radical in the denominator, right? But notice this now is a perfect square. So I have the square root of 14 over, what is the square root of 4? Well, the square root of 4 is just 2. And notice I'm multiplying 2 times 2, so I'm going to get a perfect square. Alright, and that will be your final answer. Okay, so to rationalize the denominator, you need to multiply the top and the bottom by what you have in the denominator. Okay, rationalizing the denominator. Alright, let's take a look here real quick and actually solve a problem by finding square roots. Okay? So I have 2x plus 1 equals 17. 2x squared plus 1 equals 17. Okay? Now, remember, if I'm going too fast, rewind, watch things again. That's the nice thing about having this online, is you can rewatch it. Okay? Well, our first step to solve for x should be to subtract 1. So let's subtract 1. So I have 2x squared equals 16. Okay? I still don't have my x by itself yet, so I'm going to divide by 2. Divide by 2, notice those cancel. I have x squared equals 8. Okay? X is by itself now, but it's still squared. How do you undo squaring something? Well, the opposite of squaring, okay, just like the opposite of multiplication is division, the opposite of addition is subtraction, the opposite of squaring something is square rooting something. Okay, so I want to square root both sides. Okay, these cancel, so I should get x equals the square root of 8. Alright, and hopefully in your minds you're thinking, well, we're not done yet because I have to simplify this radical. Okay, what perfect square can I take out of 8? Okay, what perfect square here can I take out of 8? Okay, we should notice I can take out a 4. Okay, so I'm going to break this down. I'm going to have the square root of 4 times the square root of, well, 4 times what equals 8? 2. 4 times 2 equals 8. Alright, what is the square root of 4? Well, the square root of 4 is 2. What is the square root of 2? It's going to be some funky decimal, so we're just going to leave it. So I have 2 square roots of 2, and that's what x equals. Okay, that's our first example of how we are going to solve by finding square roots. Now, one thing we have to be careful with is, and I actually missed this, when I take the square root of something, I need to do plus or minus. Okay, so this should be plus or minus 2 square roots of 2. plus or minus 2 square roots of 2. And the reason for that is because if I square something, it doesn't matter if it's a negative or a positive. Okay? It doesn't matter if it's a negative or a positive. 3 squared is the same as negative 3 squared. And they're both 9. So we need to make sure we have that plus or minus. Like I said, I missed that, but make sure we focus on that we get that. Okay, let's try another one here. I have 1/3 times x plus 5 squared. Oops. Equals 7. Okay. Now there's a couple ways that you can solve this. Okay. Some are going to be harder than others. You could FOIL this, distribute. Okay, but then you're going to have an x and an x squared. Okay, so we're going to try to avoid that. Now, another thing we can do is let's just get rid of this first. Okay, get rid of your multiplication, get it out of there. So I'm going to divide by 1/3, because here I'm multiplying by 1/3. Okay, keep in mind, to divide by 1/3, I actually multiply by the reciprocal, so I need to multiply both sides by 3 over 1. Okay, these cancel. I have x plus 5 squared equals 7 over 1, so I have 21 over 1. So it equals 21. Now, again, right here, you could FOIL if you wanted to. Alright, we did that in a previous section. I think that was actually yesterday. You could FOIL that if you wanted to. But another easier way is to just get rid of your square root. Right? If you see a square, go ahead and square root it. It doesn't matter what's on either side. Square root it. Those cancel. Okay, so now I just have x plus 5 over here equals the square root of 21. Okay, that's okay. This doesn't break down. Okay, notice there's no perfect squares that go into 21. Okay, 4 doesn't, 9 doesn't, 16 doesn't, and 25 is larger than it, so it obviously doesn't. Okay, that's okay if there's nothing that goes in. Okay, our problem is that we don't have x by itself yet. Well, how do I get x by itself? Okay. Oh, almost forgot again. Plus or minus. And it needs to be plus or minus square root of 21. We got to get x by itself, so I'm going to subtract 5. Okay, so I should have x equals. Always write your radical last. So I should have negative 5 plus or minus the square root of 21. Again, don't forget about that plus or minus. I almost forgot about it again. Okay, don't forget about the plus or minus. Okay. Let's do another one here. Let's solve 4x squared plus 7 equals 23. Okay. Remember, rewind, rewatch if you need to. If not, that's great. But if you need to rewatch it, go ahead and rewatch it. Okay, subtract 7. Subtract 7. Okay, so I should have 4x squared. Those cancel. 17 equals 16. Okay. Here I have 4x squared equals 16. X is still not by itself, so I'm going to divide by 4. Divide by 4. Okay. I have x squared equals 16 divided by 4 is 4. Again, x is by itself, but it's got a radical still. Or not a radical, excuse me, it's squared. We need to give it a radical, so they cancel. Square root. Okay. So now x equals plus or minus the square root of 4. Okay? The nice thing about this is it gave you a perfect square. Okay? So my final answer is going to be x equals plus or minus, the square root of 4 is 2, so it's going to be plus or minus 2. Now, the book writes it x equals 2, x equals negative 2. You can write it as plus or minus 2, that's fine. Okay, that's not a problem. X squared over 6 minus 2 equals 0. Okay, first step, we have to get this by itself. Okay, x squared over 6. We want to get x by itself, but we got to get rid of this first. Add 2, add 2. X squared over 6 equals 2. We're dividing by 6, so I need to multiply by 6. Those cancel, and x squared equals 12. Now we need to start doing our square root stuff. So we're going to square root both sides. Those cancel. And x equals plus or minus the square root of 12. Alright, break this down. Okay, I want you to pause the video for a second and try to break that down on your own, and then come back and hit play again. Alright, hopefully you found out that I can take a 4 out of this. So I should have the square root of 4 times the square root of, well, what is 12 divided by 4? It's 3. And notice 4 times 3 is 12. Alright? Don't forget about this. You're going to have to bring this down. I'm not going to write it right now, though. Okay? The square root of 4 is 2. Square root of 3 is just the square root of 3. Okay, so my final answer should be x equals plus or minus 2 square roots of 3. Okay. For your homework tonight, I want you to do page 267, 19 through 50. Alright, you will get an add-on assignment tomorrow. Tomorrow, if you forget how to do some of this, get back on Google Classroom, log back into this video, and watch some of these things again. Alright, if you forget how to do some of these, take the initiative and log back in and watch some of these videos again. And this is your assignment, which is due tomorrow. Tomorrow you will have an add-on assignment. Have a good day.